Hello everybody and welcome to this class. Today we will be focusing on some of the properties exhibited by real numbers. So this is a very important concept and we are going to study some of the basic properties that are exhibited by these type of numbers. Firstly, I want to ask you guys, I don't want anybody to tell me anything, but I just want you to think about it. What are real numbers? Now we know that most of the numbers can be classified into the following categories. So we have integers, which include whole numbers and natural numbers and negative numbers. Okay. So it would be good if you guys could wait for some time before asking me questions. Okay. So whole numbers and natural numbers and negative numbers are all part of integers. Whole numbers are all the numbers from 0 to infinity. Natural numbers are the numbers from 1 to infinity. Negative numbers are all the numbers from negative infinity to negative 1. And combining all these three types of numbers, we get integers. So we can say integers are a collection of positive, negative, and 0. Okay. Therefore, almost all of the numbers that we deal with in most day-to-day situations are integers, and most of them are usually positive numbers, so they are whole numbers. Now, there are some numbers which are not considered integers. For example, half is not an integer because it is not a positive number, it's not a negative number, and it's not 0. So we want whole numbers or negative numbers when we talk about integers. So these numbers are called rational numbers. So like half, 1/4, 2 by 8th, sorry, 2 by 9th, 11 by 19. So these are all called rational numbers. So how do we define rational numbers? Any number that can be expressed in the form P by Q, where P and Q are integers and Q is not 0, is called a rational number. Very important to understand this. Any number that can be expressed in the form P by Q, where P and Q are integers and Q is not 0, is called a rational number. Let's look at some examples. We can look at some examples. So for example, we can say minus 3 by 9 is a rational number because it's P by Q. P is the numerator, Q is the denominator, and both P and Q are integers. That's important. They should be integers, and Q is not 0. So this is a rational number. This is a rational number. This is also a rational number because 0 is an integer. We never said that P cannot be 0. We are just saying that Q cannot be 0. Remember that. The numerator can be 0. We don't mind. It is still a rational number. But the denominator cannot be 0. Therefore, 3 by 0 is not a rational number because the denominator is 0, and that has been clearly explained in the definition of rational numbers that Q is not 0. Also, this is not a rational number. At this point of time, it is not a rational number, but then we can simplify it to be 1 by 3. But let us say this was 2.3 by 6.8. This is not a rational number because 2.3 is not an integer and 6.8 is also not an integer. Remember, both p and q are integers and q is not 0. Then it is called a rational number. Okay. So what is an irrational number? Irrational number cannot be expressed in the form p by q where p and q are integers. Can you please turn off your microphone? Somebody's microphone is on. Thank you. So cannot be expressed in the form p by q where p and q are integers. Now this number 2.3 divided by 6.8, at this point of time it is not looking like a rational number because these are not integers, but this is not an irrational number because we can actually write it like this. It's the same number and this is a rational number. So technically speaking, this is not an irrational number because it can still be expressed in the form 23 by 68, and 23 and 68 are p and q, and q not equal to 0. Okay, the question is 22 by 7 an irrational number? It's not. It is a rational number. Remember, 22 by 7 is rational because the denominator and the numerator, both of them are integers and the denominator is not 0. So it's a rational number. However, is pi a rational number? It is irrational. Remember, 22 by 7 is not pi. 22 by 7 is an approximation of pi. This is why I gave that question in the exam and almost all of you got it wrong. Pi is not 3.14. Pi is not 22 by 7. 22 by 7 and 3.14 are ways of expressing pi, and you're approximating pi. They're not exactly pi. Therefore, 22 by 7 is a rational number because we have a numerator and a denominator and both of them are integers and the denominator is not 0. However, pi is not rational because the exact value of pi cannot be represented in the form p by q where p and q are integers. Okay, so what are real numbers? Real numbers are the collection of rational and irrational numbers. Real numbers are the collection of all the numbers on the number line. Important. Remember, there's a number line, right? The number line is extending to infinity on both the sides. So on the right side it goes to infinity, on the left side it goes to negative infinity, and there's 0 in the center. I'm sure all of you know a number line. So real numbers are the collection of all the numbers that can be written on the number line. So you plot any dot on the number line, it will represent some number, and that number is a real number. Okay, so between 1 and 2 you just draw a point that is a real number. Any number that can be represented on the number line is called a real number. Okay, so you're saying that pi is exactly 3.142859. No, it's not. 22 by 7 is 3.142859, but that is not pi. I'm telling this for the nth time. 22 by 7 is an approximation of pi. If you solve 22 by 7, you will get 3.142859, 142.859, 142.859, etc., etc., but that is not pi. Can you please be quiet for some time? You're sending too many questions and it is making me forget the next thing that I want to say. Just be patient. I will clarify all of that. So pi is not 22 by 7. Unfortunately, in our schools, they tell us that it is 22 by 7, and we think forever that it is 22 by 7. And when we teach it to kids and in elementary school and all of that, definitely that is the way to do it. We cannot explain it beyond that. And for most mathematical calculations, pi being 22 by 7 is sufficient to get the answer. For example, if you're calculating the area of a circle or the circumference of a circle, or you want to do something else, you just use pi as 22 by 7 or 3.14. Can you please be patient? Just wait for 2 minutes. You're asking me too many questions and then it is causing notifications to come up and I am forgetting what I want to say. Just wait for 2 minutes. I will allow you to ask the questions. Let me finish this. So for normal day-to-day use and for solving the problems in the exams and for learning elementary mathematics, keeping pi as 22 by 7 or 3.14 makes perfect sense because you cannot do operations with an irrational number. So you convert it into a rational number that looks like it, even though it's not. But in reality, pi looks something like and something like it just keeps going on and on and on. There's no pattern to it. You can look up the actual value of pi online and computers have calculated them to, tens of thousands of digits, but there's absolutely no pattern and the number just keeps going on and on and on. When I say on and on and on, I'm not talking about the bar. It's not like 3.33333. That is not an irrational number. That is still a rational number. Irrational number just randomly keeps going without any pattern. It just goes in a weird way. There is no pattern to it. The decimals just keep completely, they just generated completely randomly. So pi is an irrational number. But I told you that real numbers can be expressed on the number line. And I told you that real numbers are the collection of rational and irrational. So the question is pi a real number? Yes, because it is an irrational number and irrational numbers are also a part of real numbers. So can pi be represented on the number line? This is the thing that I want you to think about and I want you to tell me the answer in the next class. Think about, can pi be represented on the number line? We have said that all real numbers can be represented on the number line. We have said that pi is a real number. Why is pi a real number? Because it is an irrational number and irrational numbers and rational numbers come under real numbers. So if pi is a real number, can it be represented on the number line? Because this definition is telling us that all rational numbers and irrational numbers can be expressed on the number line. So can pi be represented on the number line? I want you to think about that. Okay. Now let's talk about some of the properties of real numbers. It's extremely important. We know most of the properties of integers, and let me just quickly remind you of the 5 basic properties of integer addition. Okay, so we'll talk about real number addition, and before we do real number addition, I want you to recollect about the basic properties of integer addition, not real number addition, integer addition. What is an integer? It's the collection of positive, negatives, and 0. So there are 5 properties. The first property is called closure. Closure property says that if you add any 2 integers, you will always get an integer as the answer. Pay close attention. Don't think about anything else. Just think about integers and addition. If you add any 2 integers, you will always get an integer as the answer. That is what closure property says. Commutativity says that if I have 2 integers a and b, a plus b is the same as b plus a. They should all be integers, by the way. I'm adding only integers. This is about 5 basic properties of integer addition. So if I have 2 integers a and b, let's say it's 2 and minus 89. 2 plus minus 89 is the same as minus 89 plus 2. Okay. Integer plus integer equals integer. That is closure property. Commutativity is a plus b is b plus. Associative property says that if I have three integers, then a plus b plus c can be added in any order. Okay. I could add a to b plus c, or I could even add a plus b to c. The answer will remain the same. That's what associativity says. I'm not going to explain these things much because I'm pretty sure you know these things, but I just want you to recap those things so that we think about them for real numbers. The fourth is additive identity. It says that a plus 0 is a and 0 is the additive identity, which means that I could add 0 to any integer and the answer will remain the integer itself. So the identity of the number is preserved when you add it to 0. I could take minus 3, add it to 0, and the answer is still minus 3. I could take 3 trillion and add it to 0, the answer is still 3 trillion. Okay. Then additive inverse. So additive inverse says that for every integer there exists another integer which can be added to it to get 0, and that integer is called its additive inverse. So if my a is 4, then this is minus 4, so 4 plus minus 4 is 0. If my a is minus 10, then my minus a will be minus of minus 10, which is 10. So minus 10 plus 10 will be 0. So there exists for all integers there exists another integer which is its additive inverse. So now let us talk about these things for real numbers. Okay, let's talk about them for real numbers. Do you think that if I add any two real numbers, I will always get a real number? Now there's a very simple way to prove this. There's an extremely simple way to prove this. We have said that all real numbers can be expressed on the number line. Okay, so let's say I have two real numbers and both of them can be expressed on the number line. All I have to do is measure both of them on the number line, add the two measurements, and plot another point on the number line, which is the sum of the 2 points. So real numbers are closed under addition, which means I can multiply two real numbers which means I can add two real numbers and get another real number as the answer. Commutativity also holds true. Okay. Associativity also holds true. Just because they're real numbers, it doesn't mean that any of the properties have to change. So for example, pi plus 3 is the same as 3 plus pi. So commutativity has to work out. Associativity works out, and the identity is 0. So that's there. And the inverse is also there. Okay. So there's nothing much to worry about here. But now let's look at real number division. Can I divide any two real numbers and get another real number as the answer? Think. I don't want you to type anything. Just think about it. So we did this for addition. Now we are looking at it for division, and we are seeing if all these properties work out. Can I divide any two real numbers and always get a Okay, can you hear me now? Okay, thank you. So what I said is, just think about this for some time and think if two real numbers can be divided, and will we always get a real number as the answer? The answer is no, because I could do pi divided by 0 and I will not get a real number as the answer. This is not an answer. I don't get an answer here. It's undefined. We don't know what happens when you divide by 0. So real number division is not closed. We cannot divide any two real numbers and get another real number. It's not possible. What about commutativity? If I have two real numbers a and b, is a divided by b the same as b divided by a? Once any number divided by 0 is not 0. Any number multiplied by 0 is 0, but any number divided by 0 is not 0. Please understand the basic concepts. Remember here, we are talking about numbers, irrational numbers or rational numbers, where the denominator cannot be 0. 3 divided by 0 is not a rational number, it is not an irrational number, and it is not a real number. It doesn't exist. You cannot divide anything by 0. I'll tell you why that is like that. So think of it like this. 0 divided by something is always 0, but anything divided by 0 is not 0. Let's understand why it is like that. So let's say you have 20 chocolates with you and you have to divide it among 5 people. Okay. So you have 20 chocolates. You want to divide it among 5 people. How many does each person get? 4 chocolates. Correct. Okay. Now that's how division works. Let's say we have 40 chocolates. I want to divide it among 4 people. How many chocolates does each person get? 10. I have 0 chocolates. I have to divide it among 3 people. How many chocolates does each person get? 0. I didn't have any chocolates. I have to give it to 3 people. None of them will get anything. But if I have to distribute 9 chocolates among 0 people, and if you ask me how many chocolates does each person get, it doesn't make sense, because there is nobody to whom I can give the chocolate. So you cannot ask how many chocolates did each person get. You cannot say this is 0, because it would be 0 if there was somebody who did not get a chocolate. Then I can say, see, there was this person, he didn't get any chocolates, so the answer is 0. But there is no person to whom I can give the chocolates. So you cannot say how many chocolates each person got. It could be anything, we don't know, because there is no person there. Same thing happens if you think about 0 divided by 0. You say you have no chocolates and there are no people. Okay? There are no people. And now you're asking how many chocolates did each person get? How can you answer that question? If you don't have any chocolates to give, if there is no person who is there to collect those chocolates, if you ask how many chocolates did each person get, you have no idea. I'll tell you another way to look at it. The same problem, the chocolate problem. So this is the number of chocolates, this is the number of people, and this is how many chocolates each person is getting. Okay. So if we took the number of chocolates that each person was getting, and if we multiplied it by the total number of people, we would get the total number of chocolates. Just multiplication is the reverse of division, right? So same thing here. If I say that there were 40 chocolates, 4 people, and each got 10 chocolates, I'm saying if each person got 10 chocolates, if I multiply it by the number of people, then I'll get the number of chocolates. Fine. Same thing here. Each person got 0 chocolates. There were 3 people. So the total number of chocolates is 0. Same thing here. There are 4 chocolates per person. There are 5 people. So there are a total of 20 chocolates. Now here, let's say there is some answer here. Okay, we don't know what this is. Let's say this answer is there, but we don't know it. So then if that answer was there, some answer was there. So let's say, so it's very difficult to imagine. This is a hypothetical situation. Please pay attention. I have 9 chocolates. Okay, there are 0 people. And now you're asking how many chocolates did each person get? There is nobody there, but you're asking how many chocolates each person get. So let us say that each person got some amount of chocolates. Let's imagine that such an answer exists. So then what should happen is, so each person is getting these many number of chocolates. There are these many number of people. The total should be the total number of chocolates as we saw in the previous examples. If you take the number of chocolates per person, if you multiply it by the total number of people, you should get the total number of chocolates. So we're saying there is some amount of chocolates per person. There are 0 number of people and the total should be 9. Now, how is it possible that you multiply something by 0 and get 9? You cannot. There is no person there. So whatever be the answer, you cannot multiply it to the number of people to get the number of chocolates. Correct? It's not possible. Therefore, this is not defined at all. This concept is undefined. People don't know what will happen in this situation. Can you guys please stop messaging? I don't know. I thought I had turned. How did this go off? Okay. So it's undefined. Same thing about 0 divided by 0. You have no number of chocolates. You have no number of people. And now you're asking how many chocolates do each person get? You cannot answer that question. There is no chocolates. There is no people. It cannot. It's not so simple to say that it's 0. It could be 0, but we cannot say that it is 0. It could be 3 because 3 multiplied by 0 is also 0. It could even be 1,000,000. See, this answer can also be 1,000,000 because I'm saying each person is getting 1,000,000 chocolates. Okay, so each person is getting 1,000,000 chocolates and then there is no person there. So total is 0. But it doesn't make sense, right? If each person is getting 1,000,000 chocolates and there's no person there, but the total is 0. This could be 3, this could be 4, this could be 10, this could be 1,000,000. So this is just undefined. 0 divided by 0 is not defined. And in this situation, we cannot even give examples because you cannot multiply something by 0 and get 9. So that is the concept about 0 divided by 0. That is why real numbers are not closed under division. Commutativity. A divided by B, is this the same as B divided by A? We have two real numbers, A and B. If we divide them, do we get the same thing? If both of them are the same number, then it is possible. But if they are not the same number, it is not possible. You can say that 7 divided by -4 is not the same as -4 divided by 7. It's just not the same. So division, real number division is not commutative. Okay. Not commutative. Is it associative? Can we say A divided by B divided by C? Is that the same as A divided by B divided by C? Well, let's look at some simple example. Let's say 12 divided by 6 divided by 3. There's a bracket here. Is this the same as 12 divided by 6 divided by 3? This is 12 divided by 2. So this would be 12 divided by 2, which would be 6. This would be 2 divided by 3. They're not the same. So the brackets matter a lot when you do division. And if there are no brackets given, it's always good to start from left to right. If there's only division, just keep going left to right. But if there are brackets, then first do the brackets. Not associative. Okay. Now, what is the division identity. What is the number which I can divide to any real number and preserve the identity of the number? Very good. 1. Is there a division inverse? Does every real number have another real number to it which I could divide to it to get 1? Remember, what is the meaning of inverse? Additive inverse is the number which I can add to get the additive identity, which is 0. Just a little bit of patience. There are 3 things that are involved when I talk about inverse. One is saying that it has to be added to the number, okay, to get 0, and 0 is the additive identity. So in this case, there should exist a number which we can divide to a number to get 1, because 1 is the division identity. For every number, the division inverse is the number itself, except for 0. Think for some time. You can take any number, we can divide that number by itself and we'll always get 1. Correct? We can always divide the number by itself to get 1. Just like here, how we could always add it to its inverse to get 0. In this situation, we have to always divide the number by itself to get 1, except for 0. You cannot divide 0 by anything to get 1. 0 divided by something will always be 0, and 0 divided by 0 is not defined. So there's a little bit of confusion there. So the division inverse exists for all numbers except 0. Okay. So this is talking about real numbers. Now, because this is an extremely interesting topic, and I know that most of you would have so many questions throughout this discussion, I want to ask you 3 questions only, which I will post here, which I want you to think about in addition to this. So this is the first question, and I'll give 4 more. I'll just put them here, and then after that you can ask me whatever question you want. Can pi be represented on number line? Can I add 2 real numbers to get, sorry, let's say 2 irrational numbers to get a rational number? Pay very close attention to the terminologies. Can I multiply? I want examples, okay? If it is possible, I want examples for all of these. Can I multiply 2 irrational numbers to get a rational number? Can I divide a rational number by a rational number and get something which is not a rational number? Okay, these are your 4 questions to think about. Now, I don't want any answers to these questions. Please think over them in your free time at home. And I would like to see answers to this in the next class. Do not discuss anything now about these things. These are just things for you to ponder over. Now I will answer your questions. Please feel free to ask me any question that you have about all the things that I spoke about today, because it's an interesting topic. You can even ask me things like, what is 0 to the power 0, or what is infinity, or those things are also fine, because today we are talking about real numbers and we will discuss about anything to do with numbers in general. It's a very important topic. And then we can clarify whatever confusions that might exist among ourselves. Let me be honest with you. Even I have many questions in mathematics, and I'm a junior person. I'm just doing my undergrad. There are many PhDs, there are many scholars in mathematics who will not be able to convincingly answer some simple questions, because mathematics is a very complicated subject, because it deals with many concepts that are abstract. What is the meaning of abstract? So those things cannot be seen, but they can only be imagined. It's only a hypothesis. These are all concepts that are created for the purpose of doing something else, but the concepts in themselves are not visible. So it's very difficult to explain something. It's not like a subject like chemistry or biology, where you can show something in the lab and people can actually see it and understand why it is like that. Here you have to imagine something to be true, and imagine why it is true, and imagine why it is not true. So everything happens in abstract thought, which is why it is ambiguous. Okay, so the first question: what is exact value of infinity? Okay, so infinity is a concept. So that is the first thing that you have to understand. It's not a number, it's a concept. It's a word. Okay, it's an English word. It's not a number. It's not like 3445. It's a concept, and it means that we are talking about something that is endless. It's a concept to represent endlessness. So if you ask me what is the exact value of infinity, it's not a number for which you can give a value. Can I ask you what is the exact value of an apple? It doesn't make sense, right? And when I ask value, I don't mean the rate in the market, but I'm just saying what number is an apple? You cannot say anything, because it's not a number. It's a concept. An apple is a concept. It's a fruit. It's given a name and whatever. Same thing about infinity. It's a concept. It cannot be. There's no quantification to it. But I'll tell you something interesting about it. There are two types of infinities. I don't know if you knew this. There are two types of infinities. One which is called a countable infinity, and the other which is called an uncountable infinity. Which means inside infinity there is another infinity which is a more, larger concept than a smaller infinity. So there are bigger infinities and smaller infinities. It's like there are some infinities which you can understand what they are. You cannot count them, but you can understand what they are. You can see, okay, so this is infinity, so these are the things that come under it. So that's called countable infinity. But the uncountable infinity is something which you cannot count. It's too much. There are too many things involved in it to even understand it. It's bigger than the countable infinity. It's uncountable infinity, and we will explore these concepts maybe in the next class, because they require a little bit more thought. But we can think about it some other day. Next question. I'm waiting for some other question. Can you prove the Pythagoras theorem? Okay, that I think I knew a proof maybe a few years back. I don't know if I recollect it at the tip of my tongue at this point of time, and I will think about it definitely, and I will talk about it in the next class if possible. Okay, I would want to be very. Uh, I should not fumble when I do the proof, so I just want some time to understand it again, and I will try to explain it in the next class if we have time. But let's stick to real numbers and not get into geometry. But that's a good question. There are more than 300 proofs for the Pythagoras theorem, and it's good to know at least one of them. And I promise you that I'll try to remember it and show it in the next class. Okay, next question, please. What questions do you have about real numbers that I spoke about today? What is it that you found interesting, or something that you found confusing and you feel it requires more thought? How many of you are still confused about the fact that anything divided by 0 is not defined. We don't know what it is. So that is a concept that, but actually Ramanujan was, I mean, there are many people who thought of it, but he was also one of those people who came up with the concept. He asked that exact same question in the class. He said, if I have 5 chocolates and if there is nobody to give the chocolates to, how many chocolates does each person get? Or something like that. Maybe he might have changed it a little bit, but that is what he asked. He was actually talking about division by 0. So why it is not defined is because, see here, let's say that something divided by 0 should give us some answer, then that means that 0 multiplied by that answer should be that number, right? So let's say we want to know 5 divided by 0. So now if 5 divided by 0 is x, then x multiplied by 0 should be 5. What is the meaning of multiplication? It is repeated addition. So repeated addition. So it's like you're adding the same number again and again. Now you're saying that 0 plus 0 plus 0 plus 0 plus 0 plus x number of times should equal 5. How is that possible? How will I ever reach 5 if I just go on adding zeros? We will never reach 5. We will just be stuck at 0. So x multiplied by 0 cannot be 5. It's not possible. Therefore, division by 0 is not defined. You cannot divide anything by nothing. There has to be something to divide something by. Always remember, division, you have to divide it into parts. How many parts? You say no parts. How does that make sense? Okay, what is 0 to the power 2 is your question, right? Okay, 0 to the power 2 is 0 because what is the meaning of power? It is repeated multiplication. So this is 0 times 0, which is 0. So 0 to the power 12 will also be 0 because that will be 0 times 0 times 0 times 12 times and 0, which will be 0. 0 to the power a number, you're multiplying 0 those many number of times and you'll arrive at 0. Okay. What is 2 to the power 0? That's an interesting question. What is 2 to the power 0? This is 1. Anything to the power 0 is 1. Okay, this is very important to understand. Why? Why is anything to the power 0 equal to 1? Okay, so this is how multiplication works. Remember this. We said that, okay, we didn't talk about the multiplicative identity, but I'm pretty sure all of you know that the multiplicative identity is 1, correct? So if you multiply anything by 1, the number is the same. So technically, whenever you do any multiplication, you're actually doing 3 times 4 times 1. This 1 is always there because it's the multiplicative identity. You have to multiply it by 1. So if you do 3 plus 4, it's actually 3 plus 4 plus 0. That 0 is always there because that's the additive identity. It will always be there. Okay? Can you? Okay, guys, you ask me a question and you want me to answer it, but then you start discussing about your exams and your class. I don't understand that. So please, if you ask me a question and I'm giving you an answer, please respect it and try to wait for me to finish. Okay? And I've been noticing that these days a lot of chatting is going on in the group during the class. This is not a typical group where you're supposed to chat. It is supposed to be a forum for you to ask questions only. If you have to discuss about your exam, this is not the place. Or if you have to send some emojis and memes and all that, this is not the place for that. Please understand. It will disturb the other people who are actually paying attention in the class because the two of you are continuously messaging each other. Please be patient. So whenever we do multiplication, we multiply it and we multiply by 1 because 1 is the multiplicative identity. If you do 3 plus 4, it's always 3 plus 4 plus 0 because 0 is the additive identity. So now when I say 2 to the power 5, it is actually 2 times uh, 2 times 2 times 2 times 1 because 1 is the multiplicative identity. So it will be used. Lavnish, what did I just say? Please be patient. So it will be used in every multiplication problem because it is the multiplicative identity and it is there. So then if I do 2 to the power 3, that would be 2 times 2 times 2 times 1. If I do 2 to the power 1, it will just be 2 times 1. Okay. So 2 to the power 0 will be nothing times 1. Now, when I say nothing times 1, it doesn't mean it is 0 times 1. It just means that there are no 2's. So there were 5 2's here, there were 3 2's here, there was 1 2 here. Now there will be 0 2's here. So there are no 2's. There's just the 1 that remains. Because 1 is the multiplicative identity. So you're not doing any multiplication at all. When we say anything to the power 0, it means we are not doing any multiplication at all. So we are just leaving 1 as it is. There is nothing that we are doing. Okay, so the 1 remains. Same thing if we do for 0 to the power 4, this will be 0 times 0 times 0 times 0 times 1 because 1 is the multiplicative identity, so it's there in every problem. So this will be 0. Okay, because 0 times 1 is 0. If we do 0 to the power 2, that will be 0 times 0 times 1, which is again 0. If you do 0 to the power 0, then again there are no zeros there. There is just 1 present there. This 1, the multiplicative identity, is all that remains. So there's nothing there. I'll prove this to you using addition. That will make it more understandable for you. So let's say, so you guys know that multiplication is repeated addition. Just like how raising to the power is multiplication which is repeated, when we do multiplication, it is addition which is repeated. So if I say 2 times 5, I'm technically saying 2 plus 2 plus 2 plus 2 plus 2 plus 0 because 0 is the additive identity. So we are adding 2 5 times and then that's 0. If I say 2 times 3, that is 2 plus 2 plus 2 plus 0. If I say 2 times 1, this is 2 plus 0. When I say 2 times 0, there are no 2's left. There is no 2 left. We are not using any 2's at all. So just the 0 remains. The additive identity remains. Okay. Yeah, the 1 is always there. We just don't write it. It's not necessary to be written every time, right? So because it doesn't change the answer in any way. But technically it's always there. When you always do addition, this plus 0 is there. When you always do multiplication, this times 1 is there because that is the additive or multiplicative identity. That is what preserves the number's identity. It's always there. We just don't talk about it. It's just there. So when you do 2 to the 0, then there's nothing remaining except the 1. So the 1 remains. When you do 2 times 0, there's nothing remaining except the 0. So the 0 remains. The identity remains. Okay. So we'll stop for today. And thank you so much for all your very interesting questions. And these are all nice problems to ponder over. I hope you think about these 4 problems. Okay. And I will see you guys on next Sunday. Okay, thank you so much. Please think about these problems and have a good rest of the Republic Day and happy Republic Day on my behalf. Thank you so much. Goodbye.